Bismillah ar-Rahman ar-Rahim. Today, inshallah, I'm going to explain about transformer vector group, and I will try to explain the most transformer vector group we have in electricity network, which is Dyn11. This is the most vector group that we have in our electricity network. Okay. Now, if you see this vector group in the transformer nameplate, we can understand that this D capital means the primary side of the transformer we connected as the delta. Okay, and this Y small here, this means the secondary side we connected star connection. Okay, primary side we connected as a delta, and secondary side we connected as star connection, and means we have neutral. And the most of electrical engineer, they are confusing about this number 11. So what means this 11? This 11 means the secondary side leads the primary side with phase shift 30 degree. Now let's understand how this 30 degrees come. Why 30 degree? Now if you ask you how much the phase angle between three phases R, Y, B, everyone will say 120 degree. Okay, everyone will know that the phase angle between these three phases is 120 degree. Now let's draw the clockwise like this one, and here we have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now we have this clock. Now, if you draw like this one, okay, and if you ask you how much degree now it's here, everyone will say it is 90 degree, right? Everyone will say 90 degree. Now I can say one thing, that between each hour it is 30 degree, because if you between 12 to 1, 30, 1 to 2, 30, 2 to 3, 30, so it is 90 degree. So here we understand one thing now, that between each hour it is 30 degree. Okay, now we'll remove this one. Okay, again, now I want to draw delta connection in this clock with phase angle 120 degree. So I will take the 12 clock here as a reference. So if you say between 12 to 8 to 4, like this one, delta connection, this is R capital, and this Y capital here, and this B capital here. This is the delta connection. Now let's check that between RY 120 and YB 120 and BR 120 degree. Okay, because the phase angle 120 degree. Now let's check. 30 plus 30 plus 30, 90, and here plus 30, how much? 120. Here 30, 30, 30, 90, here 30, 120 degree. Between B and R, 30, 30, 30, 30 degree here, and here we will find it is 120 degree. So I draw the delta connection with phase angle 120 degree. Okay. Now let's draw Y connection or star connection, but the star connection, the reference, it is from 11, right? From 11, because the vector group we have here 11. So this is the 11 here, like this. This will be R small, R secondary. So here this R will go to 3 to 7. Okay. Now let's check. From 11 to 3, it is 120 degree. From 3 to 7, it is 120 degree. From 7 to 11, it is 120 degree. Now I draw the delta and star with phase angle 120 degree. Now let's check this one between R capital and R small. How much phase shift between them? It is 30 degree, right? So if you see anti-clockwise direction like this one, who will lead? We will see that the secondary side lead the primary side by the phase shift 30 degree. So this why now this how phase shift 30 degree it's come. the secondary side lead the primary side with phase shift third degree, or we can say the primary side lag the secondary side by phase shift 30 degree. Okay, and this what's mean by Dyn11 in vector group. And this vector group, we need to check it. It's very important to check the vector group of the transformer. Why? Because if you want to run two power transformer in parallel, we need to check that both the power transformer has same vector group. Because if one of this transformer has different vector group, the synchronized will not happen, and maybe there will be maloperation of the protection relays. Okay, so this how this mean by the vector group Dyn11. Inshallah, next video I will try to explain how we'll test the vector group in power transformer.